Welcome to today's Explainer, where we're unpacking a massive shift happening right now in enterprise tech. We're going to explore exactly why traditional enterprise AI retrieval is hitting a very hard, very fast wall, and how a brand new approach called context architecture is stepping in to replace classic RAG. So if you've been wondering why your production AI agents keep stalling out, even when the underlying models are completely brilliant, well, you are in exactly the right place.
Here's our roadmap for this explainer. 1. AI's looming traffic jam. 2. The refrigerator analogy. 3. Enter context architecture. 4. High stakes in healthcare. And 5. The next enterprise shift. Let's get into it.
Starting off with Part 1, AI's looming traffic jam, the scale mismatch.
Okay, so there is a stark contrast at the root of this whole issue. You see, classic retrieval pipelines were fundamentally built for human queries. Think about it, right? A human types a prompt, waits, reads the response, maybe types another one. It's a single, predictable volume. But autonomous AI agents, wow. They generate requests at a volume that completely overwhelms the system. They're running in massive, parallel loops, firing off thousands of micro-requests to scattered, often stale data sources that were just, well, they were structured for humans, not for machines.
Redis CEO Rowan Trollope absolutely hit the nail on the head here. He highlighted that as companies deploy these autonomous agents, they are very quickly going to outnumber human employees. And orders of magnitude more agents means unprecedented structural loads on back-end systems. The old pipelines built for single human queries simply can't absorb this agentic volume. They just break.
Moving right along to Part 2, the refrigerator analogy, caching for agents.
Trollope actually uses this fantastic analogy that makes the whole engineering problem so incredibly easy to grasp. Imagine you want to make a sandwich. If you had to run all the way to the grocery store every single time you needed a slice of bread or a piece of cheese, that would be wildly inefficient. In this scenario, the grocery store is your main back-end database. To solve this in real life, what do? We put a refrigerator in the house. That fridge is the caching layer. It holds the local, immediate context you need to make the sandwich right now without the commute.
Comparing that classic grocery store approach directly against the fridge approach really reveals the exact bottleneck we're facing. Going to the store represents our classic database infrastructure. It's slow, it has high latency, and it's distant from where the work is actually happening. The fridge in the house, that represents this new context architecture. It gives you fast local memory with immediate access. And this is exactly the context layer AI agents desperately need to function at runtime without stalling. Because let's face it, they really can't wait for a round trip to the grocery store for every single token they generate.
Which brings us to Part 3, Enter Context Architecture with Redis Iris.
This directional contrast is massive, and it's honestly a fundamental inversion in how we build AI. With classic RAG, developers basically had to guess what the AI would need, presupposing and essentially stuffing data into the pipeline before the model was even called. We were pushing data. But context architecture flips that entirely. It treats the data layer as a live resource. So agents dynamically pull the specific data they need exactly when they need it at runtime, using tool calls. It's a total game changer.
To solve this infrastructure gap and enable that pull mechanism, Redis recently launched Iris. It's built on 5 core components that cover the entire lifecycle of agent data. You've got Redis data integration, which continuously syncs data from places like Snowflake or Oracle. Then, the context retriever lets agents query semantic models directly. Agent memory stores the state across sessions. And finally, you have the backbone of it all, Redis Flex, alongside their search and lane cache systems.
Now, I really want to highlight that Redis Flex component for a second because it fundamentally changes the economics of running AI agents. Historically, keeping data close to the processor and RAM was just incredibly expensive. Well, Redis rewrote their storage engine to run 99% of data on flash memory, SSDs, and only 1% in RAM. What does that actually mean for us? It means you get petabyte-scale retrieval at sub-millisecond latencies, but at literally a tenth of the cost of pure in-memory storage. It makes massive agent deployments finally financially viable.
Let's look at a real-world application in Part 4, high stakes in healthcare with Mangoes.ai.
Mangoes.ai is a real-time voice AI platform deployed in large healthcare facilities, a place where clinicians and patients are asking live, critical questions. Their CEO, Amit Lamba, points out that in these high-stakes environments, you absolutely cannot just stitch together separate, fragmented tools and kind of just hope they communicate properly. When someone asks about a treatment plan or a patient's case history, the AI needs instantaneous, governed context.
And that is exactly why they built natively on a unified context layer from day one.
To give you an idea of the complexity here, Mangoes handles things like a 1-hour group therapy session by running multiple specialized agents in parallel. Step 1 is entity identification. Step 2 handles relationship reasoning. And Step 3 is integrating case history. All of these agents are operating simultaneously, pulling from a shared dynamic memory state. It just goes to show that this isn't about simple document retrieval anymore, right? It's about live, complex relationship mapping.
Finally, Part 5, the next enterprise shift and where the budget is moving.
The market is moving incredibly fast right now. According to the Q1 2026 VB Pulse Tracker, buyer intent for hybrid retrieval completely tripled, jumping from just 10.3% to 33.3% in only 3 months. Enterprises are rapidly outgrowing those off-the-shelf options. They're building custom in-house retrieval stacks because they realize that the RAG layer that got them into production simply isn't robust enough to keep them there as they scale up.
On top of that, retrieval optimization has skyrocketed to nearly 29%, officially overtaking evaluation as the absolute top enterprise AI investment priority. Think about what that means for a second. Organizations spent the last year just trying to measure their AI's retrieval quality. Now, they're actively spending the budget to fix it. This context layer is no longer a maybe-later roadmap item. It is an active, urgent procurement decision today.
Stephanie Walter from Hyperframe Research points out an absolutely essential truth here. She notes that the market is converging on the fact that agents don't just need better models or more tokens. No, they need governed, current, low-latency context. The winning context layers won't just be the ones that are the fastest. They'll be the ones that fundamentally solve the governance challenge. They have to make these autonomous agents faster, cheaper, and critically safer to run without becoming these massive data access risks.
Let's end on this brilliantly provocative question from Walter, which I really want you to take away with you today. As we build out these agentic futures, she's asking us to completely shift our focus. Stop asking if you simply need to buy a vector database. Instead, ask yourself, what does your agent truly need to know? How fresh must that knowledge be to be actually useful? Who is allowed to access it? And most importantly, what does every single retrieval cost your enterprise at scale? Mastering those questions, well, that's the true key to winning in the era of context architecture.